Alright gang, it's your favorite Algebra 2 teacher. We're going to look at graphing absolute value functions today. Alright, so we've looked at absolute value equations, inequalities. Today we're going to start talking about how to graph these suckers. Now, quick review, absolute value is the distance that a number is from 0. Okay, so absolute value is a distance that a number is from 0. Quick review, the absolute value of negative 3, you guessed it, positive 3. The absolute value of positive 3 is, you guessed it, positive 3. 4 times the absolute value of 10, which would be 4 times 10, which would be 40. And then 1 minus 5, do this in first. So 3 times the absolute value of negative 4, which is 3 times 4, which is 12. Alright, so let's look at the parent function for an absolute value. Okay, so the absolute value of x. So we have our table here. What we're going to do is plug those suckers in right here. F of x equals the absolute value of negative 3, which is positive 3. So let's graph that point. Bam, there it is. Okay, so the same thing with negative 2. F of x equals the absolute value of negative 2, which is positive 2. Negative 1, positive 1. 0, 0, because 0 is 0 distance away from 0. And then 1 is positive 1, positive 2, and positive 3. So we get this nice V shape. So that's the parent function for an absolute value. Okay, that's the parent function for an absolute value. It goes through the origin, okay, and everything is positive. All right, so let's look at some transformations to that parent function. Let's look at some transformations to that parent function. So we have the absolute value of x and then plus 2. So notice here my transformations that the c is outside of my absolute value. So the first transformations we're going to talk about is when the number is outside of my absolute value. Alright, so again, let's plug our table of values into our absolute value equation. F of x equals the absolute value of negative 3 plus 2. So you get 3 plus 2, which equals 5. Alright, so now again, we're going to graph that. So I'm going to go over to negative 3. I'm going to go up 5. Bam, bop, there it is. Alright, same thing with negative 2. I'm going to plug that in. Negative 2, positive 2. And then plus 2 is negative 4. I mean, sorry, positive 4, duh. Negative 1. Plug that in, I get positive 1. 1 plus 3 is, bam, there it is. Alright, negative 1, bop, plus 3. Sorry, I already did that. What are you doing, Coach Sapp? Positive 4, positive 3, there we go. Alright, plug in 0, you get 0 plus 2. There it is. Plug in 1, you get absolute value 1. 1 plus 2 is tree. And then 4 and 5. Alright, so now we notice that the vertex, okay, the changing point on the graph is at 0, 2. Okay, if we go back up to my parent function, it was at 0, 0. Okay, alright, let's go and let's graph the next one. Let me get out a pen so that I can show you the difference. Alright, so now here we go. I'm going to plug in negative 3. So the absolute value of negative 3. And then minus 4. Absolute value of negative 3 is a positive 3. 3 minus 4 is, you guessed it, negative 1. So I'm going to plot negative 3, negative 1. There it is. Plug in negative 2, you get positive 2. 2 minus 4 is a negative 2. Plug in negative 1, you get a positive 1. 1 minus 4 is a negative 3. Plug in 0, you get 0. 0 minus 4 is a negative 4. And then we have the same thing on the other side, right? Alright, so there is your graph. So that one shifted 4 units down, right? So we're going from the parent function, which the parent function has the point at the origin. Okay, so we went down 1, 2, 3, 4 to get that point right there. Alright, in this respect, I said that we shifted up 2 units. Okay, so when the number is outside of my absolute value, we are shifting up or down. Alright, let's keep going. what about if my number is inside the absolute value? You're probably go ahead and guessing it right now. We're going to shift right and left. So let's look at which one goes which way. Here we go. All right, so I'm going to plug in this point. So I've got the absolute value of negative 3 plus 2. Negative 3 plus 2 is negative 1. The absolute value of negative 1 is a positive 1. So go over 3, go up 1. Bam, there it is. Same thing, plug in negative 2. Negative 2 plus 2 is 0. Absolute value of 0 is 0. Plug in negative 1. The absolute value of negative 1 plus 2 is a positive 1. Plug in 0 plus 2, bam. Plug in 1, you get 3. Plug in 2, you get 4. Plug in 3, you get 5. Okay, so again, from our parent function, the point was at the origin, right? So we went to the left 2 units. Okay, let's look at this one. Okay, so the difference being that this one has a plus 2 inside my absolute value. This one has a minus 1 inside my absolute value. So plus 2, we went left 2 units. Minus 1, what do you think? Maybe right 1 unit? Let's see. All right, so let's plug it in. You've got negative 3 minus 1 is a negative 4. Absolute value of a negative 4 is a positive 4. So negative 3, positive 4. Bop. There it is. Plug in negative 2, you get negative 3, but the absolute value of negative 3 is a positive 3. Negative 2, positive 3. Same thing with negative 1. Negative 1, you get a positive 2. 0, you get a positive 1. 1, you get 0. 2 minus 1, 1. And 3 minus 1, 2. Yay! All right, so the big takeaway here, okay, that sign in the parentheses, you need to do the opposite of that, right? So it's plus 2. You think to move right, but we're not moving right. That shifted it left 2 units. Same thing here, minus 1, you think we'd be shifting the graph left, but we're not. It's the opposite. We're shifting it right. All right, so let's look at our transformations, okay, and then let's just go ahead and graph those transformations based on what we know in regards to what we just learned. Here's your parent function, right? So we know that it goes through the 0, 0, the origin, and we've got our points corresponding on both sides. Okay, sorry, that kind of goes right there. All right, so now, again, if there is a transformation outside of my inequality symbol, it's moving the graph up or down. So we're moving the graph down 5 units. So my new changing point is going to be right there, and then again the corresponding points on both sides. So that transformation, without even doing the table, looks like that. If there is a transformation inside the inequality, we're going the opposite of what that says. So plus 2, we're going to go to the left 2 units. There is my new point. And then again, corresponding points on both sides. Okay, so let's talk about some multi-transformation questions. Let's see. Let's pick that one. All right, so we're going to do this first. So that means we're going to translate it down 3 units. Okay, so our new starting point is there. And then let's go ahead and take this into account. So minus 4, we're going to go to the right 4 units. So 1, 2, 3, 4. There is my new point. And then here are my corresponding points. Right, so it kind of goes off the graph. But it would look ish like that. All right, let's do one more. That one. All right, so again, no, I just did a minus 1. Let's do that one. All right, so this is going to move it down 2 units. Bop, there it is. This is going to move it left Remember, it's the opposite sign. Left 3 units. Bam! There it is. New starting point. Corresponding points on both sides. Bam, bop, boom. There it is. Easy breezy.